All right, here's the inverses. The big takeaway is that for inverses, you replace the domain with the range, or the x and the y's, especially points, will switch places. They will reverse. So as you see right here in this mapping example, you have a function. Here's the x values listed. They map or they pair up with certain range values or y values. The inverse of this exact function, the x values, were previously the y values. And so when you pair them up, they pair up with what were initially in the function, the x values. And they are now in the inverse, the y values. So on your guided notes, what was blank, you can look over here and go -3 was paired with 0, so that is what is now the y value. This question isn't one-to-one or many-to-one. What you're looking for is, are all the y values paired up with 1x? Yes, and that is for looking at the function, because that's what the question is about. Is the inverse also a function? So looking here at the inverse, for a relation, any equation, to be a function, all the x's have to be unique. They have to be different. And so yes, it is. In B, we're looking again. So you see the function, the inverse, you switch it around, all the y's now become x's. The x's now become y's. This is many-to-one for the function. So you see that at least one of the y's is paired up with 2 or more x values. So this is many-to-one. The inverse is now not a function because all of the x's are not unique, not different. And we can see this when you list out the points. And so you have -2, 4, -3, 0, 2, 1, 2, 4. So you have 2 x values in the points that are repeated. In C, we're going to graph and look at the function in the inverse. So here is a function that is graphed. That is the black dots that are graphed. And if you take all of those points and you reverse those points, then here, this point, its inverse is switch those x and y values. If you remember, that's the big takeaway. Here's 1, 2, its inverse is 2, 1. Here's 0, -3, its inverse is -3, 0. Here's 4, 1, its inverse is 1, 4. And if you map them, if you look, you notice, look, they're reflected. It's almost like they're looking in a mirror. And that is what happens with inverses. It's like they're reflected and you stuck a mirror along this y = x line. And this line has a y-intercept at 0 and has a slope of up 1 over 1, 1 over 1. And that would be where the mirror. So it does reflect around that y = x line. And it's because the, inverse replaces range domain instead of it being xy. All right, so to find an inverse, if you are given an equation, you have these 4 steps. You substitute y for f of x. You know that f of x means y. You solve for x in terms of y, and then you switch the x and the y. So you just switch those two variables. That's nothing mathematical. You just go, okay, so now I move my 2 variables. And then you replace the y again for function notation. And now what you have is the inverse. So instead of it saying f of x, what you now have as a result is the inverse of f. So it says, the way you say this is f inverse x. So here is an f of x equals 3x plus 4. So step 1, instead of having the function notation, you put in y. You know that that means f of x. So we begin solving. So we subtract 4 to begin getting x by itself. Then when we divide out that 3, and I'm going to go one step further. I'm dividing everything over here by 3. So I'm going to individually divide the y and divide the 4. So this says y divided by 3, 4 divided by 3. Step 3 is where I switch these variables. And then I flipped the entire thing. I would like my x equals to be by itself over here on the left. I'm just weird like that. But at the same time, I'm replacing x where this y is and putting y where this x is. So instead of it saying x equals, I'm going to say y equals. And instead of this being y over 3, now I say x over 3 minus 4 over 3. And then the last thing is put in that function notation. But now I have the inverse, so it's f inverse x. And I have these two graphed. So this is my original function. Here's my y-intercept of 4 and my slope of up 3 over 1. Here's the inverse that we got as a result. And sorry, I have a horrible coordinate plane. And so here's about 1 1/3. And here's up 1 and over 3. Up 1 over 3. I'll give you better coordinates to graph on. Here's something for you to see how functions and their inverses relate to each other. So here's a strange map to kind of get used to. When you compose, and we're not going to do compositions, we're going to just do inverses, but here's kind of a definition. If you do something called a composition, what you do is you have a function named g. Its output becomes the input of another function, of an f. So let's do that in terms of a function and its inverse. So the range, the y values of your function that you're doing, f, becomes the input of your inverse. And how do those relate to one another? If you take the output and turn it into the input of your inverse, what you end up getting back are the x values of your original function. So it's really weird. So if you get input values, you get your output. If they actually are, if you have the inverse of your function, and then you take those y values and you put them into your inverse, what you get out is the x values you began with. So, and that's how they behave with one another. If you actually have an inverse of a function, that's what happens to your x values. Put them into a function, you get these y values out, you stick those y values into the inverse, you get back the x values that you put in originally. Here's some one-to-one questions. Is it a function right here? Blah, blah. The big take-home message is that the range of a function is the domain of the inverse. So keep that in mind, because if we graph something, if you have a function and you can identify its range, if you go to graph the inverse, what you end up having is you've got the domain of the inverse. That's what we're doing next. So you've got this car who has a total of 14 gallons of gas. Driver stops and he's got 4 gallons right now. So he's going to go pump some gas, and it does 5 gallons per minute. So we've got this function that describes pumping the gallons of gasoline into the tank as 5t plus 4. So he's got 4 gallons already. Every minute he can get 5 gallons in. So here's the domain of the inverse. This is the range of what he's got right now. He started out at 4 gallons and he can go to 14 gallons. That's how much, kind of like y values. But for the inverse, when we find the inverse of this function, that's the x values of this inverse we're going to get. So from 4 to 14, that's what we'll have. So let's find the inverse of this function. So we're going to solve, and on your notes you have a typo. This book that I got it from, it's going through revisions. Anyway, so we're going to solve for t. So we're going to subtract 4, we're going to divide out 5, and then here is t, so that we kind of know how quickly this is going in. So if you were to graph this, it would, if you begin down here, it would be 0.8, and which seems odd because you can't start out with less than gas. But anyway, so that would be the graph of it. And it goes up 1 and over 5. And your domain is 4 to 14. All right, so those are your notes. We will talk about inverse actually later on in the week. We're going to begin with solving equations and word problems, and then we're going to go back to some systems, and you're probably not going to be happy with me because we're going to go back to some old ways of solving systems that'll be quicker. But be ready for it.